All right, let's dive into this. You sent over some pretty interesting stuff about electrical safety. Specifically, 39 essential safety tips to prevent electrocution, a must-watch for beginners. Most of us don't think too much about electrical safety, to be honest, until something bad happens. So I guess the goal here is to really break down these tips, figure out what we really need to know.
Absolutely. I mean,
to stay safe.
it's one of those things, right? We take it for granted, but until it bites back.
Oh yeah,
electricity.
Yeah, it will get you. So right off the bat, I want to talk about this idea that it's not the voltage that kills you; it's the amperage.
Right.
I've always heard that. Is it actually true though?
Well, it's a kind of misconception. I mean, voltage and amperage are both important, but they work together. You can think of voltage as the pressure in a water pipe. So higher voltage means more force pushing that electrical current. Just like more pressure is going to force more water through a pipe. And then amperage, that's the amount of electrical current flowing. So like the volume of water flowing through the pipe.
Okay, so higher voltage pushes more current, and then it's the current that actually does the damage.
Exactly. No, it is true. The amount of current flowing through your body, the amperage, that does determine how severe an electrical shock is going to be. But it's the voltage that drives that current in the first place.
Gotcha. Okay, so why isn't a car battery dangerous then? Those things have like crazy high amperage, right?
They do, but the voltage is only around 12 volts. That's not enough pressure to really push a lot of current through your dry skin. It's kind of like trying to force a lot of water through a very narrow pipe.
Oh, okay.
Just not enough pressure.
So what kind of voltage should we actually be worried about in our homes then?
So anything over 50 volts is considered dangerous. Above that level, the electricity can actually overcome your body's natural resistance and start to disrupt your internal systems.
Okay.
And remember, water drastically reduces your skin's resistance.
Right, so being wet definitely makes things even riskier.
Oh, big time.
Speaking of scary, let's get into like what electricity actually does to the human body when things go wrong.
All right. Not pretty.
No.
No. Different parts of your body are affected in different ways. So let's start with your heart.
Okay.
It has its own electrical system, right, that regulates your heartbeat. And external shock can completely mess that up, potentially leading to cardiac arrest.
Oh, wow. That's terrifying. And the source material mentions some pretty awful things about muscles, too.
Yeah. Strong electrical currents can cause intense muscle contractions. We're talking strong enough to tear muscles, fracture bones, or even dislocate joints.
It's crazy to think that a shock can make you involuntarily grip a live wire. Yeah. I've heard stories of like old school electricians testing live wires with the back of their hand to try to avoid that.
Wow.
Seems insane now.
Yeah, definitely not a recommended practice.
Oh.
And then you have internal burns. When electricity passes through your body, it generates heat. And high currents can actually burn your organs from the inside out.
Okay, well, I think we've covered enough nightmare scenarios for now, but there's another hazard we need to talk about that's often overlooked.
Right.
Arc blasts. Mm-hmm. What exactly are those?
So an arc blast or an arc flash is like a miniature lightning strike. It's an electrical explosion caused by a sudden release of energy, usually due to a fault in the system, like a short circuit.
I always thought those were more of like an industrial thing. Could they really happen like in my house?
Absolutely. They can occur anywhere where there's a sudden release of electrical energy. And the consequences can be devastating. You're talking about a pressure wave that can literally throw you across the room, intense heat that can cause instant burns, flying shrapnel from vaporized metal.
So even something as simple as like a faulty electrical panel.
It's possible, unfortunately.
Could cause an arc blast.
Yeah.
That's pretty scary. So that's why it's so crucial to have, your electrical systems regularly inspected by a qualified electrician.
Absolutely.
Okay, well, we've definitely covered the scary stuff. Now let's shift gears a little bit and talk about what we can actually do to stay safe.
Right.
Where do we even begin?
Well, the source material that we have, it actually lists 39 safety tips, but we can boil it down to some absolute must-knows.
Okay.
The first and most important, always check for voltage. before you touch anything.
Right.
Even if you think the power's off, use a multimeter to confirm.
So better safe than sorry. I mean, those things are pretty cheap compared to like a trip to the ER.
Exactly. Another essential tip is to use insulated tools. Metal wrenches, they can accidentally create a path for the current to flow.
Right.
Lead to sparks, shorts, maybe even one of those explosions we were talking about.
So no messing around with like rusty old tools.
Right.
From the garage when it comes to electrical work.
Not unless they have proper insulation.
Yeah. Okay, good point. Also, stay focused.
Yes.
When you're working with electricity. No distractions, no multitasking.
Serious stuff.
Easy to say, harder to do.
Oh, yeah.
In our world of constant distractions these days, but
right.
I guess this is one of those times when focus is really critical.
Absolutely. Treat electrical work with the seriousness it deserves.
Along the same lines, never work on electrical systems when you're tired.
No.
Fatigue leads to mistakes, and mistakes with electricity can have
big consequences.
Yeah, some pretty serious consequences. Now, what about those weird buzzing sounds that you sometimes hear?
Oh, yeah.
Coming from outlets.
Mm-hmm.
Should we be worried about those?
Sure. Those could definitely be a warning sign of a live fault. It's best to investigate carefully. Or even better, call a qualified electrician.
Okay, good advice. What about low voltage sources, like batteries? Are those still dangerous?
So while they may not have enough voltage to cause a fatal shock, they can still deliver enough current to cause burns, start fires, or damage sensitive electronics.
Okay.
So even low voltage deserves respect.
Right, good point. So no working on electrical projects while wearing your favorite metal jewelry either, right?
Right. A metal ring or a bracelet can become a dangerous conductor. If it comes into contact with an electrical source, it can heat up extremely quickly, potentially causing severe burns.
Yikes. So no bling while rewiring a lamp.
Right.
And of course, keeping your workspace dry is important too.
Absolutely. We talked about how water increases the risk of electric shock, so make sure you're not standing in a puddle or working with wet hands.
Got it. Now, this next one seems kind of counterintuitive to me. Work with one hand whenever possible.
Yeah.
Why is that?
The idea is to minimize the risk of current passing through your heart. So if you get shocked while you're only using one hand, the current is less likely to flow across your chest and disrupt your heart's electrical system.
That's actually really clever. And finally, I know this seems obvious, but it's worth repeating. Always wear protective eyewear.
Absolutely. Sparks, debris, and especially those arc flashes we talked about, those can cause serious eye damage.
Yeah. These tips are all super helpful. We've got even more to cover. Let's dive back into this in just a minute. Okay, we're back. We covered a ton of those safety tips from that first article, but you sent over another source too, right?
Yeah.
What other kind of gems does that one have for us?
Well, this one highlights some equally important points that kind of build on what we've already talked about.
Okay.
For instance, it really emphasizes those, those special outlets you see in like bathrooms and kitchens?
Yeah.
The ones with the test and reset buttons?
Oh, yeah.
Those are called ground fault circuit interrupters, or GFCIs.
Oh, yeah, GFCIs. I always wondered what those buttons were for.
Yeah.
What makes those so special?
So GFCIs, they're kind of like silent guardians. They're protecting you from shocks.
Okay.
They constantly monitor the electrical current that's flowing through them. And if they sense even a tiny imbalance, meaning some of that current might be going where it shouldn't, like through you,
Right.
they shut off the power in a fraction of a second.
So if I'm like using my hairdryer and it accidentally falls into the sink,
Yeah.
full of water,
That GFCI is going to detect that change in current flow as the electricity is trying to go through the water.
right?
And it's going to cut the power before you even realize what's happening.
Wow.
They're lifesavers, especially in those wet areas.
That's serious peace of mind. I'm definitely going to double check that all my bathroom and kitchen outlets are GFCI protected. What else does this second source emphasize?
Well, it stresses something that, we often overlook, regularly inspecting our electrical cords and our outlets for any signs of damage. Things like frayed wires, cracks in the insulation, or any exposed conductors. Those are all red flags.
Okay, so no more ignoring that, slightly frayed cord on my old lamp.
Nope. And if you do find a damaged cord, don't just slap some electrical tape on it and call it a day. That's a temporary fix at best. Replace the entire cord, or if it's an appliance, consider replacing the whole thing. It's not worth the risk.
Yeah, that's good advice. I'm also guilty of like overloading outlets sometimes.
Oh, yeah.
Is that Is that something to be really worried about?
It can be. Plugging too many devices into a single outlet or power strip can cause it to overheat,
Right.
potentially leading to a fire or even increase in the risk of an electrical shock.
So those power strips with the built-in circuit breakers
Yes,
are a good idea then.
absolutely. They provide those additional outlets and protection against those overloads.
Okay.
And try to, spread the load across different outlets and circuits throughout your home. Don't plug everything into one spot.
Right. Okay. Good to know.
Sure.
Now, this might be kind of a silly question, but how much DIY electrical work is actually safe to do?
Right.
I'm pretty handy around the house.
Yeah.
But I don't want to, end up in the ER.
So the source is pretty clear on this one. Unless you have the proper knowledge and training, it's best to leave electrical work to the professionals.
Okay.
Electricity is unforgiven, and those improper installations or repairs, they can create some serious hazards.
Right. Call an electrician. Got it. Especially with all the, crazy storms we've been having lately.
Oh, yeah.
Are there any specific safety tips for dealing with electricity during severe weather?
Definitely. Lightning strikes and power surges, they can really wreak havoc on your electrical system. The source recommends unplugging those sensitive electronics like computers and televisions during thunderstorms. In fact, it's best to avoid using any corded electrical devices altogether during a storm.
So I guess curling up with a good book is the best option then.
Exactly. And one more thing about storms, stay away from windows. You don't want to be anywhere near a potential electrical pathway if lightning does strike.
That makes sense. We talk a lot about outlets and appliances. What about extension cords? Any safety tips for those?
Oh, absolutely. The source is full of warnings about misusing extension cords.
Right.
Never run them under carpets or over doorways or in high-traffic areas where they could get stepped on or damaged.
So they're really meant to be like a temporary solution, not a permanent fixture.
Exactly. If you find yourself relying on extension cords all the time, it's probably a sign that you need more outlets or circuits installed in your home. A qualified electrician can help you with that.
Right. Okay. That's really helpful advice. Now, before we wrap up, how can we tell if there's a potential electrical problem lurking in our homes that we might not be aware of?
Right. Well, the source material actually gives some good telltale signs to watch out for.
Okay.
Things like, lights flicker, circuit breakers trip in frequently, buzzing sounds coming from outlets or switches, or any unusual burn-in smells.
So if I notice any of those, time to call in a professional.
Without a doubt, it's always better to be safe than sorry when it comes to electricity. Don't ignore those warning signs. They're trying to tell you something.
It seems like the overarching message here is that we really need to respect the power of electricity.
Absolutely. And both of these sources drive that point home. Electricity doesn't care about your experience level. It only cares if you follow the rules.
So no matter how much you think you know,
Right.
complacency can be dangerous,
Exactly.
even deadly.
Always be cautious, never take shortcuts, and remember that electricity demands respect.
I think we've really gone through, pretty much everything about electrical safety today.
Yeah.
From the science behind it, the voltage and the amperage, all the way to, those scary arc blasts, those life-saving GFCIs. We've covered a lot of ground.
It's been quite a journey, and hopefully you're leaving here with a renewed sense of awareness
Yeah.
and a whole toolbox of tips to stay safe.
I know I am. But before we wrap up, I want to shift gears a little bit and talk about something that we haven't really touched on yet. We've talked about all those physical dangers
Yeah.
of electricity in a lot of detail. But what about the psychological aspect of it?
That's an interesting point. What do you mean?
Well, think about it. Electricity is this invisible force, right? We can't see it, smell it, or taste it. It's just there,
Right.
silently powering our lives. But it has this incredible potential for danger, just lurking beneath the surface.
Right.
It's almost like a primal fear.
Yeah.
This unseen force that can both, sustain us and harm us
Yeah.
in an instant.
It's true.
And I wonder how that really shapes our relationship with electricity.
Right.
Do we just take it for granted because it's so ingrained in our everyday lives? Or do we have a healthy respect for its power?
Those are great questions. And I think they're definitely worth pondering. Maybe this deep dive has not only increased our awareness of the physical dangers, but also sparked a deeper appreciation for that delicate balance we have
Right.
with electricity.
It's not about living in fear of electricity.
Right.
It's about understanding it,
Right.
respecting its limits, and taking those precautions
Ah.
to, coexist safely with it. This incredibly powerful force.
Couldn't have said it better myself. So, to our listeners, keep exploring the fascinating world of electricity. Stay curious, stay informed, and above all, stay safe.